When ions move across the membrane, they either depolarize the cell or they hyperpolarize the cell. So polarization just means a charge. And we see here that a cell at rest, here's the resting membrane potential. Potential is another word for voltage. So this is the voltage, minus 70 millivolts at rest of a cell. Minus 70, it has a charge. So it is polarized. So if we do something to make it greater, more polarized, we say we hyperpolarize it. And if we do something to move it closer to zero, we counter that depolarization or depolarize it. So how do we do that? Well, we know that if we open up a sodium channel, sodium will rush into the cell based on the electrical and chemical gradient. The sodium ions are positive. More positives inside the cell are going to make this less negative. So opening up a sodium channel, allowing sodium to come into the cell, will depolarize the cell. Now on the flip side, if we open up a potassium channel, potassium is going to want to go out based on the chemical gradient. So positive ions leaving the cell, potassium is positive, will make it more negative, less positive or more negative. So opening up a potassium channel will actually hyperpolarize the cell. Also, if we open up a chloride channel, which wants to move into the cell based on the chemical gradient, and also has a negative charge, because of that, opening up a chloride channel will allow more negatives to come in and create greater polarization or a hyperpolarization. So we have one way to depolarize a cell. Simply open up a sodium channel and let the sodium ions move according to the electrical chemical gradient. And we have two ways to hyperpolarize a cell. Either open up a potassium channel or a chloride channel and let their electrical chemical gradients do the rest.